Hi there, it's Chris here from Technify Networks. The purpose of this video is to show you how to configure HSRP on the Cisco IRS router. Before we jump into action, I'm just going to be running through a brief theory. HSRP is a type of FHRP, which stands for First Hop Redundancy Protocol. And FHRP is used to ensure network availability and to eliminate a single point of failure in the network. It is basically used to create redundancy and to prevent network failure at the default gateway. And there are three types of FHRP. So we have HSRP, which stands for Hot Standby Router Protocol, and it's a Cisco proprietary protocol. And VRRP stands for Virtual Router Redundancy Protocol, which is an open standard and is similar to HSRP. And we have GLBP, which stands for Gateway Load Balancing Protocol. It's Cisco proprietary as well, and it supports load balancing. So HSRP is going to be our main focus today. It's Cisco proprietary and is described in the RFC 2281. And in HSRP, we have the active and standby router roles. Like the active router is the one forwarding traffic on behalf of the virtual router. So we're going to be seeing that when we're doing the configuration. And preemption is not enabled by default. And then we have two versions. The version 1 uses MAC address quadruple 0.0C07.ACXS, and the XS stands for the group number. It will be the hexadecimal value of the group number if we configure group 11, for example. So this will be AC0B. That will be the hexadecimal value for that. And for the version 2 MAC address, starts with quadruple 0.0C9F.F and then the triple X. The triple X also stands for the hexadecimal value of the group number. And for version 1, it sends the HSRP packets to the multicast address 224.0.0.2. And for the version 2, it sends it to 224.0.0.102. And then the default hello timer is 3 seconds, and the default hold time is 10 seconds, basically. So we're just going to be jumping into action quickly. And this is a topology we're going to be using for this. I've got some configuration done already, IP address assigned already on the ISP router and and static routes to our LAN here. And then I've assigned IP addresses here. And then the only thing I need to do now is to configure OSPF and then configure HSRP on these two routers. So this is the virtual gateway we're going to be using for our virtual router, which is 192.168.23.1. But first of all, what I'm going to do is to configure OSPF here. So I'm going to, on our customer edge router, I'm going to say enable, and then let's say show IP int brief, just to verify our IP address is here. Yeah, it's configured. So we're just gonna go conft and say router OSPF 1. And then we're gonna say router ID 1.1.1.1. So then we're gonna enable OSPF with the interface command. So we're gonna exit and we're gonna go to interface giga 00, say IP OSPF 1 area 0, that's the backbone. So then we're gonna exit that. I'm gonna go to interface gigabit 01 and say IP OSPF 1 area 0. And then we're gonna exit that. So we're gonna configure a default static route to the ISP towards the internet. So we're gonna say IP route 0.0.0.0, 0.0.0.0. Then the next up IP will be 100 192.14.14.2, which is the IP address of this interface on the ISP router. So then we say enter. So, and then we go to OSPF again, and then we're going to redistribute this into OSPF with the command default information originate. So then is able to distribute that to these two other routers when OSPF is enabled on them. So we're going to say do right to save the running config to the startup config, and then we can say Ctrl Z to exit that. Let's confirm our default static route, show IP route. Here is there. So we're gonna go to these routers. Okay, let's start with router 2. I'm gonna expand this quickly. So I'm gonna say enable conft. So I'm gonna go to do show IP interface brief. Yeah, we've only got that IP address assigned to that interface. So what I'm gonna do is I'm gonna configure OSPF. I'm gonna say router OSPF 1 router ID 2.2.2.2. Then I'm gonna go to the interface giga 00. I enable OSPF IP OSPF 1 area 0 should be connected to the backbone, and then there is a neighborship is up. So what I'm gonna do here now is I'm gonna finish off the configuration on this router. So let's change the host name to R2. So let's say exit host name R2. So I'm gonna go to this interface, to our gateway interface, and then configure OSPF and configure HSRP there as well. So I'm gonna go to interface giga 01, and I'm gonna say no shot. So I'm gonna say IP address. So that'll be 192.168.23.2, and then I'm gonna say 255.255.255.0/24. So then I'm gonna say IP OSPF 1. So let's do this as area 2. So then we'll start with the HSRP configuration. So we're gonna say standby 11 will be the group number. So if I use the question mark, you can see standby then the group number. So we can use 11 as the group number IP. So and then the standby IP will be the IP address of the virtual gateway, which is the virtual router basically. So we're saying 192.168.23.1, and then I'll say standby 11, the group number. Let's say priority, we want to increase the priority to 150. So because the default priority is 100, we want this to be an active router at all times. Then it's active already, but then we can now say standby 11 preempt. So whenever it goes down and it comes back up, there's going to be an election process. As long as it's got the highest priority, it's going to be the active router. So then that's that for that. So let's say do right, save the running config to the startup config, and then we go to router 3. We do the same configuration, but we can just confirm our configuration there first quickly. So Ctrl Z, let's say show standby. So that's the configuration we just did, and then we can see that the group number is group 11 and the state is active. And then the virtual IP address is 192.168.23.1, that was the intended address. And then we can see the virtual MAC address. Because we use group 11, we've got 0B. That's the hexadecimal value of it. So, and then the load time is 3 seconds and the hold time is 10 seconds. And then we've got the active router as a local, but the standby, we've not configured this yet, so is unknown. And the priority that we gave was 150. So that's about that. So we're going to jump to router 3. So I'm going to expand this a bit. Expand this. So then enable conft. Then we're going to configure OSPF. Say router OSPF 1. OSPF 1. Then the router ID will be free. So that's that for the OSPF configuration. So we exit. And then by the time there should be a neighborship now. Okay, we need to go to interface gigabit 01 and then to put that in area 0 IP OSPF 1 area 0. So then the neighborship will be up and we should be able to be seeing the default route that was configured there. Do show IP route as an E2 route, basically. Yeah, it's there. So because it's external, it was redistributed into OSPF. That's that route there. So now we're gonna go into the gigabit 00. Let's exit here. Interface gigabit 00. So we're gonna say no shots. So we're gonna put that IP address first. IP address 192.168.23. I think that should be .3. Yeah, .3. Then subnet mask 255.255.255.0. So we're gonna enable OSPF here. So this should be in area 2 in order to form adjacency with these. They have to be in the same area. So IP OSPF 1 area 2. So the neighborship should be up. We router 2. We just wait for that neighborship to come up. We wait. Yeah, that neighborship is up now. So if we do show IP OSPF neighbors. So yeah, we've got 2 neighbors, router 1 and router 2. So now we're gonna start with our standby with our HSRP configuration on this interface. So which is standby. The group is group 11 IP, and then we have 192.168.23.1 as our standby IP. So we should be fine with that. And then the default priority here is 100 anyway. So what we just do is we're just gonna say do show standby brief. Standby. Okay, standby only now. Yeah. So now that's standby. So yeah, everything is still like, okay, the virtual IP address, that's for this, the virtual gateway. And then we can see that the state, okay, it was on speak when we did that. So let's do that again. Then so that we can see that the state is now in standby. So then we'll say the virtual address here, that's that, and the MAC address is AC0B, just like the other one, like router 2. So and then we've got the load time, which is 3 seconds, and then we've got the hold time, which is 10 seconds. So then preemption is not enabled here. The active router is 23.2, which is the IP address of router 2. So and the priority is 100. That's default priority. So we just say do right. And then what we're going to do is to go to our PC. So we're going to assign an IP address to our PC, and then the default gateway will be our virtual gateway. So desktop, so our PC should be 192.168.23.5. So the default gateway is 192.168.23.1. So then we're going to ping 888. We're going to ping this server on the internet. So, and then we're going to do a trace route to make sure it's going through our active router. So ping 8.8.8.8. So the first one might be an app packet, which might time out here, and the second one should go through. So we're just waiting for this ping for the reply. So we're gonna try that again. We shouldn't have any issues with that. Let's try again. We have a default route to the internet. There shouldn't be a problem. So let's see why the ping is failing. It's timing out. So we're gonna check our configurations here. Initially, let's go here and show IP interface brief. So we've got 23.2 and we've got here 21.2 there. So that's fine. And let's see, I say show IP route. Yeah, we've got our route there. So if we ping from here, yeah, so we shouldn't have a problem here. So if that can ping that, okay, let's ping our virtual gateway first, ping 192.168.23.1. So we can ping our virtual gateway. So we shouldn't have any problems. Let's ping 192.168.23.2 as well. Yeah, we can ping that. So there shouldn't be a problem here at all. So let's ping 888 again. Let's ping 888 again. We are waiting for 888 to return. We are waiting for the reply. So there must have been an issue here. If this is failing, it shouldn't fail basically. Okay, what I can do here is to change this PC if there is an issue, just to see if there is an issue with this PC. I'm gonna change it. So I'm gonna do that. I'm gonna delete that. Escape. I'm gonna put another PC there. So then I'm gonna put the cable, because we don't have any reasons for that to fail if we can reach. Okay, so desktop IP address is 192.168.23.5, 255.255, then 192.168.23.1. That's our virtual gateway. So we're gonna ping our virtual gateway first. Ping 192.168.23.1. Yeah, that works. So we're gonna try 23.2. That works. We are able to ping that. So, and then we're gonna try 23.3. That's fine. and then we're gonna ping 8.8.8.8 again. So we are waiting for the ICMP echo reply. It's timing out. We have our default route configured, so this should not happen. This should not happen, basically. So we've got, let's check the ISP router. ISP router, we do have that. Okay, I think what I'm gonna do is enable. Okay, let's see something here. Let's see if OSPF knows about this. Show IP route. Okay, I think where the problem is we do not have this. It has to be in area 0, basically. I think that's where the problem is. This network has to be in area 0. Yeah, we don't have it in OSPF. So it has to be in area 0. So we're just gonna go back to R2 and say conft no IP OSPF 1 area 2. And yeah, we're just gonna say, yeah, okay, interface gigabit 01, no IP OSPF 1 area 2. So IP OSPF 1 area 0. So then we're gonna tear down the adjacency there as well and do the same thing. So yeah, we've got it. So no IP OSPF 1 area 2. And then we do IP OSPF 1 area 0. So the neighborship should come back up. So and then R1 should know of this. So then we should be able to now ping. Let's do show IP route again. So R1 is now aware of this network, is now learning it. So now we are able to ping from there. Okay, that's an OSPF lesson. So now we should be able to ping 888 here. So we are fine now. We are back in business. So what we'll need to do is to now trace RT 88888. So it's going to be going through 23.2. So we're going to do a continuous ping, and then we're going to detach that link, and we're going to see how it's going to switch over. It's going to drop some packets. So from PC1, then we're just going to shut down this interface. So let me do that. I put router 2 here, and then I put, where is our PC1, put in PC1 there. So I'm gonna shut down that interface, shut, and then it's gonna go down, then the standby router 3 is gonna become the active router. That's why we are losing, is dropping these packets here. Let's drop the second one. So it's gonna pick up on router 3 now. router 3 will become the active router now. So we're gonna see successful pings soon. Normally the SPF algorithm is recalculating the route, so it might take a while. Yeah, so now it's picking up again. So now we're gonna do the trace route again, and then we're gonna see that it's now going through router 3. So we're gonna do Control C, we're gonna do trace routes. So we can see it's going to router 323.3. So if you find this video help, okay, what we're gonna do is to now go back to this, and then we'll say no shutdown on router 2 so that it becomes the active router again. So if we do interface gigabit 01, let's say no shot. So if we ping again and now trace the route, is gonna, okay, we do fast forward for this to be green. Okay, so we're gonna ping 888 now again, and then we're gonna trace the ping 888. So it might take 1 or 2 minutes. Yeah, okay. So now we're gonna see the path is gonna be from router 2 again. So it's now going back through the active router. So if you find this video helpful, give it a thumbs up and subscribe to our YouTube channel. Thanks for watching. Until next time, bye.